So let's start our second session on the deep learning. So today's session we will slowly increase our pace, and also we will set up our foundation on the deep learning. Wait a minute, we have covered so far. Yes. So this is the last lecture. This was the last PPT that we covered, and we saw the difference between machine learning and the deep learning. And we found that in the deep learning, my architecture, or you can say that network itself, do the feature extraction. So these things we saw in the deep learning. So if you talk about the deep learning, or you can say that what we have in the deep learning. So in the deep learning, basically, we are mimic the human neuron system, which I already have covered in the last lecture. So what we have is that in our human brain, we have the very complex architecture of my neurons. So similarly, we try to create these things in our deep learning architecture. So if I show you the how this neuron works, or how this neuron looks like, so let me just show you some picture of the neuron, and we create the same thing. Let me just reduce the size. Okay. Yeah. So now if we study a neuron, so neuron contains some axon terminal which takes the inputs. If you see this portion, so using this axon terminal, it takes the input, and then we have the axon which contain the shell things, and this axon is process the input. And then after that we have the dendrites which pass the information to the next neuron. So if I talk about this axon terminal, this takes the input, then we have the axon which process the input, or you can say that process the information. And then we have the dendrites, which is useful to pass the information to the next neuron. So when we have the dendrites, so dendrites, the use of the dendrites is pass the processed information. Okay, pass the relevant information to the next neuron. This is how a neuron works. And if I show you that how the neuron architecture we have, so neuron interaction. If I show you this neuron interaction, wait a minute. So this is the neuron interaction. You can see that the dendrites of the another neuron will pass to the axon terminal of the next neuron. So this is how the neuron pass the information from the one neuron to another neuron. So this is the complex architecture that we have, and we mimic the same architecture. So if I talk about in the deep learning, if I talk about a artificial neural network, so artificial neural network will be nothing but this collection of these neurons. So in this one, the circle is representing the all these neurons, and these neurons are connected with each other. Now, here the question comes that how we mimic the human neurons, right? The question comes that we are saying that we are mimicking the human neuron, but how, right? So if I talk about this neuron, so like these things, we have the axon terminals, and then after that we have the axome, and then after that we have the dendrites. So this is the axon terminal. This is the axon, and now this is the dendrites. So to mimic this neuron architecture, to mimic this neuron functionalities, our neurologist, plus mathematician studied the nature of these neurons and tried to implement these things with the help of some mathematical function. So we found that it should be something like this one, that we are passing some input, then we perform some calculation, and then after that we are getting the output. Here, if you see the nature of the neuron, when we studied this nature of this neuron, we found that neuron fires or neuron pass the information, neurons pass a particular information. When I say the particular information, it means that it is not necessary that neuron pass the information. Based on a specific condition, neuron pass the information to the next neuron. Otherwise, it will discard this information. Let me tell you one this example. So maybe now you are maybe now you are looking at your screen and listening my voice, or you are just paying your attention to the laptop screen. But apart from the laptop screen, you can easily see the items on your table or your nearby items, but your brain is not processing this information. Am I right? You can see the easily some items placed on your table or your nearby your laptop, but your brain is not processing this information. Your brain is only processing the information which comes through the my voice and from this laptop screen. Am I right? Yes or no, guys? Just visualize these things. So your brain is only processing the information which comes through my voice and the laptop screen. Although you can see the nearby things like your wall, your laptop table. You can watch some kind of a like you can see your family also, but your brain is not processing this information. Your brain is totally focused on the laptop screen and this my voice, right? So this is how a human neuron is also work. So behind the scene, human neuron pass the relevant information to the brain to process. It's not pass the entire information. Although your eyes is capturing lot of information apart from your laptop screen, but your human neuron is not passing the things. So the same thing is also we are implementing here. So we are only passing the relevant information with the help of the activation functions. So now we have the concept of the activation function. Now we have the concept of the activation function. In this activation function, we process the information and pass to the next neuron. Okay. And now let's understand the architecture, how we create this architecture. As you have seen that in the human brain, we have the millions of neurons, and one neuron is interacting with the other neuron and pass the information. So same kind of a things we are going to mimic here. So we are also going to mimic the same information that we are going to have a this complex architecture where information is passed to the one neuron to the another neuron. So let me just explain you this thing. So now I'm defining the one artificial neural network, ANN, you can say that. In this artificial neural network, we are going to create the network of the neurons. So I'm just representing this neuron by the circle. I'm taking a very simple example of the four neurons. Okay, so please pay attention. I'm just covering some important points about the artificial neural network. So for example, I have a image which contain 2 cross 2 pixel, or you can say that, or another example is that you have a data which contain the 4 features: x1, x2, x3, x4. So now we have the 4 inputs. So x1, x2, x3, and x4. So what we are doing is, now this input of x1, this is my input layer. This is my hidden layer. Both will be my hidden layer. And this is my output layer. So this is my hidden layer 1. This is my hidden layer 2. And this is my output layer. And now this is the architecture. So my x1 input, the x1 input will pass to the each next neuron. Please pay attention, guys. I'm just covering the most important part of this deep learning, because once you understood this architecture, how the deep learning network we create, then other things will be just the implementation on the top of this architecture. Okay, so please pay attention. So one input of x1 will pass to the each next neuron. Similarly, this x2 will also pass to the each next neuron. Similarly, the x3 is also passed to the each next neuron. Okay, so this is how we are passing to the each input. If I talk about this neuron, so this neuron is containing the all the 4 inputs, right? So now if you remember, like what I mentioned earlier, that when our neuron take the entire information, it not process the entire information, right? you will see that like you can see the nearby things around you, but you are not, your brain is not processing it. So definitely behind the thing, behind the this neuron, there will be some kind of a calculation then how the things working. So now let me just explain you these things here. So each neuron, I'm just explaining this neuron, guys. I am explaining this neuron. So this neuron is containing the this input. So this neuron is passing. This neuron is getting these inputs. So these inputs are the x1, x2, x3, x4. So x1, x2, x3, and x4. So we are passing this information, and then after that, along with this information, as I mentioned that it is not necessary that it is not necessary that all the inputs should have the equal weightage, right? Maybe this input x2 and x3 is related to the your laptop. So definitely this information will be the most important information. X1 information is your side by things, your side by table. This X1 information is not that much important to process. X4 information is the audio, so definitely it will be the also important. So the thing is to just process this information, which my architecture has to learn that how to process this information. I am associating a weight along with these inputs. So if you see these things, I'm putting a weight one superscript 1 1, where 1 is represent the layer. So this is between the input layer and the hidden layer 1, and this first is represent the first layer, first neuron, and first value. So similarly, we have the 1 1 2, then 1 1 3, and then W1 1 4. So these are the weight associated that we have. And if I talk about the concept wise, this concept is pretty similar that you have seen in the logistic regression or the linear regression also. So in the linear regression, you also have seen that to create a linear line, we are doing the coefficient into my features, and then we start learning these coefficients. Am I right? So you also have seen these things that in the case of the linear regression, you also perform the multiplication of your linear features. Sorry, you multiply the features with the coefficients. So here we call this coefficient as a weight. So this part is clear to you. This part is clear to you guys. Say yes or no if you are able to get these things. If you are not able to get these things, I will repeat these things. If everyone is able to get these things, please let me know. Otherwise, please let me know. If I want to repeat, I can repeat also. So along with the each input, x1, x2, x3, x4, we are passing a weight associated with these inputs. And then inside this neuron, we are doing the two process. Inside this neuron, we are doing the two process. So one process is your multiplication of your weight and bias, multiplication of your weight and features plus bias. So here it will be W11 X1 plus W112 X2 plus W113 X3 plus W114 X4 plus bias. As I mentioned that we like this, it is the same example, it is the same concept that you have seen in the linear regression. In the linear regression also, you have to perform the things in the same manner. You have to multiply your coefficient along with the features and adding the bias. And then after that, this is my first activity that I'm doing in the neuron. And the second activity is I'm passing these things to the some mathematical function. We call it as a activation function. We are passing this information to the some some function which we call it as a activation function. This activation function we will see in the next lecture. Okay. So now this type of calculation we are doing here. So for this one, we are assigning the weight W111. This is the one W112, W113, and W114. And this will be the bias B1. After processing these things, they will pass some output. Similarly, for this neuron, we will have the different weight, right? Because this neuron is different from this neuron. So the information is, although the information is coming same, but this neuron responsibility is different from the previous neuron. So here also, we use the different weight here. So weight will be, for this neuron, weight will be W121, W122, W123, and W124. This is my different weight that we have. Again, for this one, bias will be B2, and there will be some output. Let's call it as a output as a H111 hidden hidden layer 1, first neuron, then H12, let me take out. Can you please explain the bias again? So Manish, bias is the same concept if you remember in the linear regression. In the linear regression also, when we are creating a line equation, the line equation was beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3, where here beta naught is the bias. So here also we are using the same concept. To adjust my equation, we are using the bias concept. Okay, so basically it is nothing but the linear equation that you saw in the linear regression.
Yes, Harish. So the concept is clear, but then what is the bias value? Is this W1x1, W11x1 plus W1x2? Is this the bias value?
No. Bias value is the B1, no?
Okay, it's a independent value. Okay.
Yes, independent
Mm,
value. If
okay.
you see these things, uh, what I'm doing is I'm I'm writing it W11x1 plus W112x2 plus W113x3 plus W14x x5
Okay.
15 x5
And then
plus
plus B. Okay, bias. There is a bias inside the formula. Okay.
yes. So after this calculation,
So sorry, Harish, one more question. What is this sigma? Like before this formula, you have a
yes, this is the
if
activation function. We will cover it,
okay, okay,
we will
okay,
discuss it later.
okay.
This is the activation function.
Okay.
So
Harish,
similarly, the third
can we
neuron is
call I'm sorry to interrupt. I'm sorry to interrupt. Can we call this bias as an intercept in line equation?
Yes, you can correlate with the intercept, but
Yeah.
in the deep learning term, we call it as a bias.
Yep. Yep. Got
Okay.
Okay. So definitely it is like in the linear equation, it is the intercept perfectly. But in the deep learning terminology, we call it as a bias. Okay.
Oh,
Now, third neuron is also generate some output. I'm calling it as a H13, first hidden layer, third neuron, then H14, first hidden layer, fourth neuron. I'm just using this notation to make our calculation easy. Otherwise, it will be very difficult to visualize. And H15, first hidden layer, fifth neuron. So now this is my nothing but H11, right? H11 is nothing but the activation of function of my W11x1 plus W12x2 plus W13x3 plus W14x4 plus your bias, because we have the 4 input along with the 4 weight plus 1 bias. So if you got this concept, can you please give me the value of H12? What will be the value of H12? I'm expecting the answer in the chats. I'm expecting the answer from everyone in the chat section. So if you understood this concept, please give me that how H12 looks like in terms of the formula. Sigma represents the activation function and other things represent the weight. Please take your time, write these things carefully, and I'm expecting the everyone. So please don't just listen the things. Please be active in this session. Otherwise, it will be difficult to grasp the remaining concept in the coming lectures. So please understand this concept. Try to write the things for the H12. So what is the output or what this contains is H12. Let me check your responses. I'm expecting, because we have 17 learners in this call, so I'm expecting the answer from everyone, guys. Please do it. So let me just check. Okay, so sigma W2 1 W2 this 3 plus bias 2. Okay. Shubham is W2 sigma. Shivraj just mentioned the sigma also. I mean activation function. W211, W212, X2, that's good. Adame is also good. S2 is your sigma, W1, yes, this is also good. Princey, the bias is itself in the sigma also. But okay, please don't, this sigma is implemented, the activation function is implemented inside the on that bias as well. Okay, so put, I think, Princey and Rakesh. So you also put these things outside. So these things is also under the equation, because this is my sigma is implemented. My sigma will be implemented on the entire line equation. So it will be applicable on the B2 as well. So write the entire line equation and put the sigma on the top of it. Dhanlakshmi give the right. Yes, Dipanshi is also correct. Aisha is yes correct. Yes, Vikas is also correct. Himaraju is also correct. And Shiva is also correct. Please make it as a bias tools. Okay, that's good. So one mistake that I found from the few learners is that they are excluding the bias. They're putting the bias out of the sigma equation. No, it is the same part. So similarly, you have seen that H12 is there, H13 is there, H14 we definitely in the same way. we have the H14 and H15 and so on. So we have the now the 5 outputs coming from the hidden layer 1, and now for the hidden layer 2, my H11, H12, H13, H14, H15 will become the input. So for the next hidden layer, my previous hidden layer output will become the input. So I'm passing this value to the next zero. Like these things, we are passing, like these things, we are passing the output of my first hidden layer to the input of the another hidden layers. So now the question comes that, Harish, we have seen some weights here, and are we using the same weights here? So tell me, guys, so the weight pattern will be same or different? What do you think? Now the weight that we use in the input layer and the hidden layer 1, what do you think? It will remain the same or the different? Yes, guys, it will be the different, because again, this is the information, and at every stage it will be the different. So now I'm just explaining. So this value will give me the, if I talk about the output, let's assume that this output is the H21, 2 is represent the hidden state, sorry, hidden layer, H21, and then H22, then H23, and then H24. Like these things, we will get the output. And now I'm explaining the, or if you are got this concept, if you got this concept, can you please tell me that what we will have, for the H12? Can you please write the equation for the H21? Sorry, H21. Can you please write the equation for the H21? Just imagine that what I just want to see that whether you're on the right track or not. Although I will write these things again. Just anyone who thinking that how the things will work in the H21. Okay, H11, W1, H12, W2, H3. Shivaraj, what about the H15? Shivaraj, we also have the H15 as well.
Yeah, understood.
So sigma is HW21. Yes, H15, that's good, because H1, 1, 2, 1, 3, 1, 4. Himaraju, we have the H15. Please correct these things also. Dana Lakshmi, yes, it is correct. And Shubham is also this. That's good. So the main thing is that now, as I mentioned, that for H21, my input will be the hidden layer output, the first hidden layer output. So I'm writing these things for the other learners also. So let me write it in the different color so that you can keep it separate. So H21, which is the hidden layer 2 and first neuron, it will be the, first of all, for the input for the H21, we have seen that input is H11, H12, H13, H14, and H15. So this will be my input. And the next thing is, definitely along with this input, we will have the we will have the weight associated. And again, weight will be the different for the each neuron. Weight will be the different from the previous one. So here, weight will be the W211, W212, W213, W214, and for the last one is W215. So we have the 5 input, and along with the 5 input, we have the 5 weight. And then definitely we have the bias. So I call this bias as a B11, and this bias will be B21. So this is the bias B21. And now if I multiply, if I just write the things, so inside the sigma function, we on the top of this, we will see this thing in the coming lecture. So activation function will be that my W211 H11 plus W212 H12 plus W313 H3 plus W414 H14 plus W15 H5 plus your bias, which is the B21. This is the value that we have. And now this value will give me the H21, similarly H22 and H22. Okay, so this is how the information passed through one layer to the another layer. And now similarly, this H21 will pass to the my output layer. And this output will be my, let's call it as a P1 and P2. This is my P1 and P2, guys. So P1 is also, you will have the same structures that we have seen that. So now let me use this terminology. I'm writing on the screen. So now if I talk about the P1, P1 will be again the same sigma of your W311 H21 plus W312 H22 plus W313 H23 plus W314 H24 plus some bias it will be B31. This will be your P1 or your predicted values. This is your predicted values. So this part is clear to you. Please let me know. Similarly, we will have the P2, and here the weight are the W311, W312, W313, and W3. So this is the weight associated with the inputs. Can you please do check these things and let me know if you have any doubt in the calculation. If you have any doubt in the entire calculation, please let me know. Or if you want me to revise the things one more time, I can also do these things.
Can you give us a live example that how how this thing is happening actually, whether in a normal life or in artificial?
No, can you please repeat? Can you please speak louder a little bit?
Yeah, what I'm saying is, can you please give us a live example like how thing is happening actually in artificial intelligence or in normal thing like
Okay,
live.
okay, that's a good question. Let me show you the things also. So one of the learner doubt is that Harish, I want to visualize these things. Okay, as of now, you are just mentioning these things, but can we visualize the things, how the things are going? So yes, we can do these things. And application wise, also, I will tell you this application. I'm just showing you the TensorFlow playground. Let me show you the real-time example. So I have a application which is provided by the Google. Google is just giving you this information. So just imagine that. Just imagine, guys, please pay attention here. Just imagine that I have a data set which contain the some blue dots which represent the one class. We have the orange dots which represent the another class. And now I want to perform this classification with the help of the artificial neural network. The problem statement is clear to you. I have a problem. I have a class. You can call it as a blue dot is as a. I think you got which problem you worked on the classification, guys? I think it's a lone one, right? So you can call it as a. This is the blue one is the defaulter, and orange one is the fully paid. And now we have the input x1 and x2. I'm using the one hidden layer which contain the 4 neuron, and let's make it as a 5 neuron because in the example I was taking the 5 neuron. And then after that I'm doing one more hidden layers which contain the 4 neuron, right? This is what I'm doing it. And then after that we have the output layer. So this is my architecture. You have the input like x1, x2, one neuron, one layer, and another layer, and then output layer. Now I'm running this architecture. So you will see that now we have the two, there is no boundary, but now my artificial neural network will start working on this and we will create some boundary in between. So now you can see that easily we can see a boundary separator between these things. One is this is the blue portion, this is the orange portion. And you can see that quickly within the few iterations, we are able to perform these things. The activation function, I'm using the 10H. I can use the ReLU as well. I will show you these things in the coming lectures. So this is your again the class. So this is how we can perform the classification with the artificial neural network. You can see that this is how the value is passing. So corresponding to the x1, if you see this, my cursor, they are showing that Harish corresponding to the x1 weight is 0.1 minus 0.10, and for the x2 weight is 0.26. Similarly, for this neuron, we are getting the four input. One is 0.22 weight, another is minus 0.45, third one is 0.22, 0.028, fourth one is 0.34, and fifth one is your fifth one is 0.34, and this is your fourth one, and this is 0.18, minus 0.15, and 0.2. So if you see these things, they are attaching the weight along with it, and also for these things, one bias will be there. And now you can see that higher the some weight will be, the some lines are very dark in color, and the lines which are dark in color to represent your high weightage. When I say the high weightage, it means that they are just telling you that information coming from the this neuron is very important, and that's why we are giving the high weightage. So this is my artificial neural network on its problems. And now I'm taking a one complex data. This type my data looks like this one. So let's see that how this artificial neural network architecture that we have created to solve this problem. So if I play these things, you can see that this time the problem is complex, taking a lot of iterations, but now it performed the things quite clearly. You can see the boundary. My orange are on the one side, and my blue dots are on the one side. I'm taking a one complex architecture, a complex application. Now you can see that this is very complex application or the data where we have the inside the blue dots and outside the orange dots. If I run these things, let's see that you can see that it starts creating a separator between the this one, and now you can see these things. It's clearly separable. So this part is your blue boundary, and on the outside we have the orange things. Okay, so can you please open this link just in the Google, just type the TensorFlow Playground, you will get this link.
So this like how this artificial neural network will understand like which is the most important. Like if you say that weight is there, right? Weight means the line is dark, but
Yes.
how it will know like why it is important? Like for example, you said that one information is like you speaking, and one information is table or the
Okay.
laptop. Right. So we understand that table will not provide us anything.
Correct.
Same way, how this AI artificial neural network will understand that which one is the important one. And I think the weights are decided. The weights are decided on this logic only, right? Like which
Yes,
information is
correct,
more important.
correct.
But
I
how it
got,
will.
yeah, I got your question completely. So my counter question to you is, I mean, although like I will cover these things also, I will cover these things, how this learning process happens, because this today is our second lecture, and my main intention was to just show you this architecture. My main intention was to just show you this architecture, and then in the next lecture, probably we can take this thing in the next lecture or the day after next lecture, how the learning happens. Okay. Although as
Right.
you ask this question, I'm just clarify these things here as well. If you remember, your linear regression things, can you please tell me how the linear regression algorithms learns, or how you find the optimal weights in the linear regression line?
So in linear regression line, the optimal weights are where the minimum error is there, maximum accuracy is there, and then that is like when we use the Python tool, right? Then it automatically calculates like the coefficients value and the constant value, right? So the constant value and the coefficient value, whichever value is there for the maximum accuracy or best fit, what do you call the best
So
fit?
my question is that how did you achieve this best fit? How did you achieve this best fit that, hey, Harish, this coefficient is the best coefficient? How?
Yes,
Where the
Harish.
slope is zero, right? Where the slope is minimum.
No.
Yeah,
Maximum.
Harish, I would like to
Yeah, please,
like put my
discuss
word.
it. Yeah, please.
Actually, in linear regression, the main goal is to find the global minima where
Yes,
it will settle down through gradient descent, and there that point finds the best fit line, and
perfect.
that is
Yeah,
where we linear regression comes into place.
yes.
Thank
I
you.
think everyone will be agree with this statement that I'm just reiterating these things. So basically, in the linear regression, I'm not going the deep. So in the linear regressions, we start with the random weights and random bias, or you can say that your coefficient or the intercept. So you start with the random coefficient and the random intercept. You got the loss corresponding these things with the loss function. Then you use a optimization algorithms which you are calling it as a gradient descent, and you are calling this gradient descent algorithms to find the local minima, and corresponding to this local minima we are getting the optimal weights, correct? Am I right?
Yep. Yep.
Just give me a minute, guys. Okay, so yeah, I'm back. So this is the process. So if you see these things, if you see this process, so you are mentioning that, Harish, I mean, we have the random weights, then loss function, then the optimization. The same thing we are also going to do here. Okay, there is no change in the process. The only thing is the way that we perform the things. Okay, because as of now, I just created this foundation. So that's why because we don't have the time to just cover entire things. So, so same thing will be happen here as well. We will calculate the predicted values. Now my W11, W112, all these are the random weights that I will start. And then after that, I will also check here in this deep learning also, I will check the loss as well. I will also use some loss function here. I will check the loss here. And then after that, as you mentioned that, Harish, we had uh, we had this gradient descent. So the same thing we are also going to implement here to optimize my weights. This is clear to you now?
Yes, I think I'll just check, like I'll just revise that.
Yeah, no problem. We will discuss these things. So no need to worry about. We will see that how this learning happens. And any other doubt apart from this doubt?
And then that tensor flow diagram, right? There is an elbow that is formed when we are creating the clusters on the
No,
right side of.
we don't have any algorithm concept here.
No,
We have the concept of the
I'm saying that
network.
this elbow curve kind of thing is there, right? Test loss and training loss in the output.
Can you speak loudly?
Yeah, yeah. I'm saying that there is a elbow curve that is formed here, right?
Oh, elbow curve. Okay, elbow curve. Yes, yes.
This is same as when we are deciding the number of clusters.
No. You are in the wrong direction. Let me just tell you the things. No, no, let me just clarify this thing right now. Otherwise, it will be a very big trouble for you. This is for everyone, guys. So this elbow is not the elbow method, guys. This is the loss. So this curve is telling you that initially my loss was here, slowly decrease, and a situation will come where it will become the constant. And now, if you do the more iteration, there is no scope to reduce the more loss, and it become a constant. This is graph of your training loss and the test loss. See, this is not the elbow graph. This is the graph of how loss is decreasing with iterations. That's it. This is not the elbow graph. This is make sense to you now?
Yes,
I mean, it's the similar concept only, right? Like you are varying your loss against your iterations, which is the even the elbow
Same.
says the same thing.
Remember, right? No, no, no. This is not from the elbow. Don't.
No, I'm just saying from the concept perspective, it is again we are measuring the loss against the number
Yes,
of
yes,
iterations.
yes, yes, yes. Concept is same. That's why if you see these things, remember when I was explaining the deep learning, I was calling it as a like these things. This is ML, this is DL. Am I right? Remember? Remember, guys, I was writing this thing as a this is ML and some portion is common. So this is the portion is common. So the concept is still the same. The concept that we have is predicted values, actual values, loss, optimization. All this concept will remain the same. Please clarify your doubts, whatever the doubts that you have. That's good that you are asking these doubts, guys, because it will clarify. It will also make my works easy in the upcoming classes, and also you will be fully understand the concept. Please ask your doubts.
So these number of neurons in the middle layer, is there any like guideline on how what is the best number for the
These things we will
particular data
perform
set?
the experiment. We
Okay.
don't know whether the 5 is good, whether the 4 is good, whether the 20 is good, whether 30 is good. The main thing is that one thing you have seen that by adding the numbers of neurons, we are adding the number of trainable parameters or the weight. Or in the deep learning terms, I will say when I'm adding the number of neurons, when I'm adding the number of neuron, we are adding the, we are making my model complex. Okay. So now I'm using the 5 neuron and you can see that my model is pretty stable. I can perform this classification very well. If I use the model with the 20 neurons, at that time also your model will be again perform the classification, but your model will be very, very complex. And also when you are using the high complex model, the chance of overfitting will be high. Am I right? Can you please confirm these things also? If your model is very complex, the chance of overfitting is also high. Yes or no?
Yes.
Right?
Yes.
So there is no hard line. There is no hard line for the number of neuron that you should use. This is totally based on my problem. This is totally based on my data, that for this data, how much complex model we need to create. If you create the more complex model, again, it is a problem. If you create a very basic model, again, it is a problem. So we have to just wisely choose the number of neurons, and these things comes with the experiment, with the experience as well. and slowly you will also understand the things when you will perform a uh, some kind of a hands-on in the real time. Now it's clear to you?
Yes.
Any other doubt?
No. No.
Okay, from any other learners, please let me know. Okay, so I am assuming no doubt. So now we will discuss these things more in depth. So now we have seen that this is my architecture looks like. On this architecture, I want to first thing I want to tell you here is in the deep learning, my weight and bias are trainable parameters. When I say the trainable parameters, it means that this weight and bias, this weight and bias will be updated during my learning process or during my training process. So when somebody asks you that what are the trainable parameters that you have in the deep learning architecture or the deep learning network, so your weight and bias are the trainable parameter. So basically, we have to update these weights, this bias, these weights, this bias, like these things. Okay. So now I want to calculate the number of trainable parameters. So I want to calculate the number of trainable parameters. So I'm just giving you a first 2 to 3 minutes. You will see that in this, in between input layer and the output layer, you were using some weights and bias here. Similarly, between the hidden layer and the hidden layer 2, hidden layer 1 and the hidden layer 2, again we are using some weight and bias. And again, between hidden layer 2 and the output layer, again we are using some weight and bias. So let's start with very step by steps. I want to see the trainable parameter between input layer and hidden layer 1. Can you please think and give me a number that what is the total weight and bias in this between the input and the hidden layer, and give me this answer privately in chat, guys. Okay, don't mention these things. I just want to see the learners responses. Okay, so if you are calculated these things, if you are done with your calculation, that what will be how many trainable weights parameters will be we will have, you can post your number in the chat section. Okay, my question is again that I'm not interested in the weight and bias, I'm interested in the total trainable parameters. Yeah, let me check your responses. Okay, so let me check your responses one by one. Okay, so Manish, it's wrong. It will be the okay. So let me just give the answer. Okay, let me just check your responses first. Hemaraju, okay. Shubham is also give the answer. That's good, Shubham. Manali is also give the correct answer. Shivaraj is also Shivaraj give the wrong answer. Shivaraj. Okay, now let me just explain the things first. Let me explain the things first. Okay. But that's good that you did a very good attempt. So now let me just explain you the things. So my question was the total trainable parameters. So let's talk about this neuron. So this neuron containing the 4 inputs, and each input is associated with a weight. So we will have the 4 weight plus 1 bias. So we will have the 4 weight and 1 bias, and total will be the 5 trainable parameters. So this will contain the 5 trainable parameters. For this process will also 5 trainable parameter. This process is also 5 trainable parameter. This is also 5 trainable parameters, and this is also the 5 trainable parameter, because bias will be different. Every time my bias will be different. This will contain the B11, this will contain the B12, this will contain the B13, this will contain the B14, this will contain the B15. So total parameters will be 5. Total trainable parameter will be 5 into 5, which will be the 25. I saw the response. Most of the learners give the correct response, but I found some kind of a incorrect answer also. So where the learner has the confusion about the bias, I think. So for the each neuron, my bias will be different. So now this is clear to everyone. This is clear to everyone, especially the learners who gave the wrong answer. So this is clear to you.
Yes.
Okay, great. So now if it is clear to you, can you please give me the value between the hidden layer 1 and hidden layer 2? Can you please give me the value between the hidden layer 1 and hidden layer 2? Let me check your responses. Okay, so it's a 21. Let's see. So each neuron contain the 5 weight and 1 bias. It will be the 6, and 6 for the 24. That is the perfect answer. Now the next one is between the hidden layer 2 and the output layer. So what will be the trainable parameter between the hidden layer 2 and the output layer? Yes, everyone give the right answer. So for this one, the trainable parameters will be 4 plus 1, 5 is here, and 4 plus 1, 5 is here. The total will be 10. And total here it will be 24 plus 6 for the 24, 25 plus 24 plus 10. So total will be 49 plus 50, 10 plus 59. So these are my trainable parameters. Okay. And when we build the model, we will use the TensorFlow library to show the how many trainable parameters. And more number of trainable parameters means more complex model. Okay. So this thing is also we have to keep in mind that more trainable parameter means more complex model. So this is the how my neuron architecture looks like.
Sir, for output, don't we have bias?
Sorry, this output
Sir,
P1? No,
yeah,
this is the P. No, this is the P1, right? P1 is nothing but yes.
yes.
Here it will contain the bias, right? Here in this one, because it's a
Yes,
neuron,
sir.
right?
So,
But
so
yeah,
we,
P1.
so we don't need to consider in the weight side for the output thing. It's only 4.
No, bias will be there. Bias will be there. For the P1 also, it will be like, I mean, weight H21, H22, H23, H24 plus bias. For the P1
Sir,
also,
I
we will
have
have
a
the bias.
small confusion. I'll explain. Sir, in the hidden layer 1, we added 1 bias, so it became 5, right?
No.
Yes,
We have the
then,
bias with the each neuron.
yes. Sir. Sir, we made it 5, right? Sir, please write it 5 there, sir. Somewhere.
Okay,
In one
so
side.
B11, B12,
Yeah, so write 5 somewhere, sir. Yes, 5.
5. Okay, 5.
Yes.
Okay.
So when we went to the hidden layer 2, we added 5 plus 1 more bias, right? So it became 6.
No. Okay, for the this hidden layer, 5 is the input
Hmm. Yes.
and 1 is bias. 1 is the bias means this neuron bias.
Okay.
It will become the 6.
Okay.
For this neuron, 4 is the inputs. That's why 4 will be the weight. So it will be the 4W and 1 bias.
One. No, I got it, sir. Thanks.
Okay.
Yeah, got it. Yes, thanks.
Okay. So if you got this concept, let me give you a one question and then we will jump into the next problem. Next means we will discuss some more examples and then after that we will end this session for today and tomorrow we will again do this kind of a things which we already have seen like sigmoid function, all these stuffs. I'm just creating now a little bit complex architecture with more So this is my artificial neural network architecture. Can you please give me the number of neurons? Sorry, number of trainable parameters. When I'm saying that number of trainable parameters, it includes both weight and bias. Okay. Please check these things and give me the answer privately, guys. Don't give the answer to the everyone because others also calculating the things. Okay, if you are done, privately just ping me. Okay.
You want the total in all the layers, right?
Yes, I want the one number, final number, that how many trainable parameters that I have in this network.
So I have a general question.
Yes.
When normally for every classification or the regression, so there is one or the other model which can be used to elevate those output, right? Like the regression values
No,
classification.
can please let me speak loudly. I don't know like whether it's an
Yeah.
issue from my side or
Yeah. So I mean, for every classification problem or the regression problem, we have the ML models which can be used, right? Okay, so under what circumstances or how exactly we will decide whether to use any ML model or any deep learning technique?
okay. So let me just clarify these things also as when you ask these things. So regression classification is not only between the between the structured data, it is also between the images as well, video as well, right? For example, I want to perform the image classification. Okay, I want to perform the video classification. Like if you remember in the last lecture, I gave the example that in the deep learning, one person was doing suicide, and then he was doing the Facebook. I think I took this example, right? Hello, I took this example, guys.
Yeah, right, yeah.
Right. So basically that person was doing suicide and so he was doing the through the Facebook Live. So Facebook Live is also using the video classification to differentiate a good video and inappropriate video. So these things cannot be classified using the machine learning algorithms because the input parameters on which we train the model is very, very huge. I will show you these things when we will go in the deep of the deep learning. The input parameters will be very huge and the traditional machine learning approach will not work here. So we have to perform the complex architecture. This is where the deep learning came in the picture. It's clear? So classification is not only that we have between the only for the ML. So this classification things is a general things, right? Regression classification, these are the general things. Clear now?
Yeah, got it.
Any other doubt? So I was expecting this answer. So Vikas, right answer. Manjuli, right answer. Adamya, right answer. Shubham, right answer. Hemaraju, please check your answer again. It's 177, 171. Yes. Okay, Dipanshu, please check your answer. Rahul, check your answer. Shivraj, check your answer. So the right answer is 171. Okay, I'm just writing these things. So I'm just calculating these things to just show you the learners, other learners. So we have 1, 2, 3, 4, 5, 6, 7. So this will be the 7 input plus 1 bias. So trainable parameters will be 8. And we have 1, 2, 3, 4, 5, 6. So 8, 6 into 6, 8, 6 is a 48. Then we have 1, 2, 3, 4, 5, 6. 6 plus 1 is the 7 trainable parameter here. And 1, 2, 3, 4, 5, 6. And 7 into 6 is 42. Then after that, we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So 6 plus 1, 7 is the trainable parameter in the each neuron here. And we have 1, 2, 3, 4, 5, 6, 7. 7 into 7, 49. Then after that, for this one, we have 1, 2, 3, 4, 5, 6, 7. 7 plus 1 is 8. And this one contain 8, this one contain 8, this will contain 8, and this will also contain 8. So this will be 32. So this is the right. Any doubt? Okay, I'm assuming no then. So this is the deep learning. As I mentioned that like one circle is represent the neuron, and this is my complex architectures that we have. And if I talk about the performance, you can see that as we are increasing the neural network size, the performance will increase, but after a certain period of time, it will convert into the overfitting. If we talk about the deep learning implementation nowadays, so nowadays the use of the deep learning rised exponentially. Okay, so let's discuss some theory things again to just create the interest in the deep learning. And as I mentioned that from the last few years, the use of the deep learning increased exponentially because from the last few years, the data the data upload and download over the internet is also rise exponentially, and now we don't have the traditional structured data. We have the data in the form of the images, we have the data in the form of the text data, video data, audio data. So the form is different, and also we are playing with the huge data. Just imagine that you are working as a data scientist in Facebook. So in the Facebook, the data which is uploaded per hour is also very huge. I'm not talking about the per day, even the data uploading per hour is also very huge in the Facebook. So definitely to process this kind of a data, we need a more complex architecture, and that's why we use the deep learnings. So the another use of the deep learning architecture is to solve the complex problems or a huge data. If I talk about the some very famous architecture already present in the deep learning. So one of the architecture is the ImageNet. ImageNet is a model which is developed by the one of the company. I forget that name. I think it's maybe Facebook or the Facebook created, I think, AlexNet. So I think it's maybe Google. So they developed this architecture to perform the classification on the general purpose category, like your cat, dog, your kitchen items, your hat, like these things. So this architecture is already present in the market, so we can also use them these things. So another is the you have the AlexNet. So they are also mentioning these things that YouTube is also using this kind of a classification things to classify your videos, and Facebook is also Facebook is also using these techniques to recognize the face and your friends. If you remember these things, if you remember, I'm talking about this 4 to 5 years back. Facebook launched a feature to automatically tag your friends. Are you aware of these things?
Yes.
Facebook have a feature to automatically tag your friends. So these things we have is also developed by the deep learning things. So we have question from the Hema Raju. So do we have the topics that we'll cover in the entire course? So Hema, I think there will be a course of content will be already shared to with you already, right? So can you please confirm these things also, guys? So this is the topic that I got it. So basically, we will cover the artificial neural network, we will cover the recurrent neural network, we will cover the CNN architecture, and we will cover the autoencoder or the advanced level of LSTM and GRU. Then after that, we will also see the TensorFlow. We will, while writing the code, we will see the TensorFlow. We will see that how we can build the regression classification things using the TensorFlow. We will also see the Keras and basics of the LSTM, this PyTorch, and then we will spend some time on the computer vision to process the image and perform the object detection using the OpenCV library. So this is my course of curriculum that I received.
Okay, got it.
Okay, so now let me just cover and then so deep face is also one of the example where Facebook launched this deep learning model, and now this is a latest example that we have. So this is a very famous example of the AlphaGo. So AlphaGo is a game. I don't know whether you have seen this documentary or not. So over the internet or over the YouTube, we have this documentary. So we have this documentary already available. So here, basically, DeepMind developed a deep learning based algorithms, which learn on the AlphaGo game. It is a game very similar to the chess, which played in the South Korea. So now they challenge the human, they challenge the top ranking player to play against the machine. And if you see these things in the second version of this algorithms, AlphaGo defeated the 18 times world champions very easily. See this thing, guys. I mean, this documentary is already available over the internet also. If you want to see this entire documentary, how they created these algorithms and how the things happened, so you can see that a person who is 18 times world champion, so this computer game, or not the computer game, this deep learning model uh, defeated him easily. So these are the few very breakthrough improvement or breakthrough advancement in the deep learning architecture. Nowadays, many video games is also using these architectures. Many video games is using this deep learning based model to create your game into the real time things. Okay, so these are the few examples that we have. Apart from these things, we have the self-driving cars. So self-driving car is, I'm not going in the deep of the self-driving car, but self-driving car is also using the multiple deep learning models for the object detection, object classification, and create these things. Okay, so these are the few examples that we have, and in the next lecture we will directly jump into the more technical things.